We did a couple of talks, one with data natives, one with the data natives VentureBeat event, and now you're here from Austin, Texas.
Well, just from Austin.
Just from Austin, not Texas, guys. There's no Texas in Austin, yeah? There's like Austin and then there's Texas. So, yeah, so I guess like it would be good to start maybe with a question about why is it important to have this conversation here at Data Natives. I mean, we're going to be talking about quantum computing, and I want to introduce Whurley in a bit, but maybe first I want to like warm up everybody with this question of like, why is it important to have this conversation here at Data Natives, a data science conference?
Well, data science and quantum computing are on a collision course or an intercept course, depending on how you look at it. And so when you think about the future of data science, when you think about the future of science in general, quantum is going to dramatically change all of that. And so at StrangeWorks, we often speak to people outside the quantum community to let them know what's coming, to bring them into the fold, to help be a resource, because it will be one of the biggest impacts on all computing science we've ever seen. I often say between now and the end of the decade, quantum computing will change computing more than it's changed in its entirety.
Which is already quite big, right? If you think about it, computers used to be like a whole entire room, right? And now it's essentially this phone where I have my notes. It's like a mini computer stored in my brain, let's say, and other locations, hopefully. But like we already started here. How many of you, because we have this topic of quantum computing, how many of you have been to Whurley's talk in the morning? Most of you. Okay, cool. So this is probably a follow-up or like something that takes off from your talk.
How many of you had questions that didn't get answered and you're just back to ask the question? None of you? Oh, perfect.
Shy people. Oh,
this will be easy.
Everybody has questions. This is the one, they're too intimidated. Talking about quantum computing. So then, for the rest of you who haven't been here in the talk in the morning, I would love to hear a little bit from Whurley and his background, because we really jumped in about why we're doing this talk here, this conversation. But maybe, Whurley, we hear a little bit about you. So now you're a founder of StrangeWorks, but you're doing a lot of different things. Tell us about it, like your background.
Yes, I mean, this is very boring, but I started my career in 1993 at Apple answering the phones, and then ended up heading the training programs and then working in R&D. And then I went to IBM from Apple in 1997 because the cultures were so identical, not. And from there, I joined my first startup in 2000, and it was a miserable failure. But I saw this potential for startups, this potential for not having all the rules, not having all the systems, and kind of just freewheeling around. And so I spent from 2000 to 2009 bouncing between large companies and startups. So I worked at a bunch of big system management companies like Tivoli and BMC. I worked at a bunch of startups in cybersecurity and other areas. And I spent the time kind of gathering data on what were the good parts of the startups and what were the bad parts, and what were the good parts of the corporations and what were the bad parts. And then in 2009, I left to do my first startup, which was called Chaotic Moon in the mobile space, and I tried to blend those two worlds, those two models. And that went really, really well. It grew extraordinarily well and eventually sold to Accenture. We did a spin out in gaming that was bought by Zynga. And then in 2015, I wasn't sure if it was the system or me or the people I hired or how much of it, was my credit, right? Because startups are a team sport. And so I said, I want to start another startup with some new people. And we started a startup in the fintech space called Honest Dollar. And we launched it at South by Southwest in 2015. And then I went on CNBC in March of 2016 at South by and said, we've been acquired by Goldman Sachs. And so I spent a couple of years on the management team there trying to get them to do quantum, and they weren't that interested. And so I said, hey, I want to go do a side project. And that was a Linux Foundation project that didn't take off because none of the quantum people wanted to work together. So I said, well, I'll just start a company and do it myself. And so here I am at another startup, much to the disappointment of my wife and my family and everyone, because the Linux Foundation was going to be my retirement job. So I'm now out of retirement.
But you're not retiring, exactly.
Right.
Like, you don't want to retire. Yes, you also, when we were talking about it, you mentioned that your wife calls it a sci-fi project. And
yes.
when I took on the lead to moderate this, since I'm not a I'm not a scientist, and for me this is sci-fi. Like maybe we can actually start by explaining a little bit for our audience, since there are a lot of different kinds, from data enthusiasts to scientists to entrepreneurs and AI experts. Like, what exactly does it mean quantum in the future, right? And what do we need to keep an eye for? Like, how much sci-fi can it get?
So that's a great question, and the thing that you want to keep an eye out for, the thing that's going on right now, is the search for what's called quantum advantage. And for those of you that were in the talk earlier, I demonstrated that white paper. That's one of the first real examples of some form of quantum advantage. I wouldn't say that it's mind-blowing, but it's very, very solid. Quantum advantage being defined as when a quantum computer can do something that a classical computer is incapable of doing, not just by time standards, but at all. So the paper by Preskel and that team is very important, but you're gonna have a problem if you're watching out for cues to start getting into quantum. The thing I tell people, and I actually just did another panel in London from my hotel room, and this question came up, and I just said, listen, if you're not already thinking about quantum and into quantum and kind of following it, you could already be too late. I use the example when I started. When I started, 3 architectures on machines. Now there's over 9. 0 publicly traded companies. Now there's 4. 4 university programs. Now there's, I found out my number's incorrect. There's 52. So that's all in 4 years. And the $30 billion, $10 billion of which was invested just in the last 4 years, is driving that faster and faster. So, think of quantum like a train passing up here. And right now, as data scientists, we're down here by, at Whurley having a beer, and we see the train going by. We're like, we should be on that train. It might be going somewhere. But the train is already going somewhere, right? We're just not on it. So I would encourage everybody to really dive into it today. Do you need to quit your job and try to find a job in quantum? No, and there may not be one for you. But should this be something that's at the forefront of what you're looking at? For data science, I think absolutely. For any science, I think it's imperative that people start educating themselves. I feel like for the last 5 or 6 years that I've been in the community, I've been running around like Chicken Little. The sky's falling, like quantum's coming, and I just can't. I spend a lot of time with the government in the U.S. on Capitol Hill. I spend a lot of time traveling around the world, and the reason I do it, is, we don't get paid for these. We do these voluntarily. We don't advertise our product, right? We just talk about the subject. The reason this is so important to us is we're trying to evangelize this to as many people as possible, because it will be one of the greatest technological changes in the history of our species. And if I walk outside, nobody even has heard of quantum, right?
So what can you do with it? So give us an example of how this can make our life better.
Well, a data scientist at Mitsubishi used quantum annealing and optimization to take the route of the trash trucks from 2,300 kilometers a day to 1,100 kilometers a day, right? So clearly there's a tangible savings and efficiency there. We didn't use that when I used the German examples earlier, right? But Frankfurt Airport has 170,000 passengers traversing it every day. And they use that to optimize the routes between the gates, where planes land, all of this optimization. So that's where you use it today. In the very near-term future, pharmaceuticals, new drug discovery, things of that nature, material science discoveries, things of that nature. So think of it this way. Are you modeling nature? You're doing a digital twin. You're trying to do something. Take a caffeine, molecule. So you would need enough storage memory, like RAM memory, that'd be the size of like Germany or the Earth, to be able to store that information. But a quantum computer could do that in 160 qubits. And right now, you can use a 127 qubit machine from IBM today, and in a few months, a 433. So, it's very important, but I think most people are focused on optimization things now. Machine learning optimization being very important to this audience, and one of the areas you can do things right now. But in the future, it's material sciences, it's pharma, it's new forms of finance. I, however, don't have any of those as my interest. I don't care about any of that. I don't care about better drug discovery. I care about eliminating disease, right? I don't care about quantum chemistry for a better battery. that's going to make the electric cars more efficient. I care about completely new forms of travel that we haven't even thought of. The way I like people to think of it is, think about everything that you use today and go back 10 years. How much of it was there? Go back 15 years. There wasn't an iPhone, right? Go back 20 years, 30 years, 40 years. You know, you see the massive leaps that we've made, but you see all the things that were created out of technology that was new. So going to the moon to building the internet at CERN, you're going to have that whole clock start over with quantum, in my opinion. So there would be trillions of dollars of opportunities over the next 10, 20, 30 years that nobody's even thinking of. They'll have nothing to do with anything that we do today. They'll have to do with, you know, maybe teleportation or maybe completely new currencies or all of the sci-fi things. Those are why I'm interested in quantum computing.
And will that require a new kind of skill sets to be able to keep up with this and to be able to be part of this change, let's say? Because, I mean, we're talking about here
Sure.
data science, right? And on one hand, and sorry to, like, just to finish my train of thought, to not forget, because you made some really interesting remarks. So we're talking about data science, and on one hand, I think for a data scientist, not having to store all the data, it's really important and useful. And it's also important and useful for so many reasons, energy included, right? Because it's much more sustainable not to have all this data stored in places. That's like one of the biggest problems when it comes to energy for computation. But then what I'm thinking as well is, okay, you were describing this future, and we already see here, right, that for the current life that we're living, even now, there's a lot of new opportunities that come up. Like data scientist as a term was not even existent before like 5-10 years. So what will be the skill sets of the person working with quantum computing?
So I don't think that changes. For me, the skill set that's required in technology is always creativity, right? Is the most important thing as a software developer, as an engineer, as whatever, is thinking about these problems, you know, differently. But I'll also tell you that the skill sets we need now, you know, the algorithms are linear algebra. So, right, you need to have some math skills. If you're going to debug it, you need some physics skills, right? You need some software development skills. I mean, it's pretty standard right now. That's going to change dramatically over the next, you know, 5, 10, 15 years. But that's how it's always at. As you said, data scientists didn't exist, right? And now it's a whole industry. So skills are, you know, people acquire skills as the times change. So, you know, can I tell you what skills? I mean, it depends on the type of machine and what becomes popular and what the winner is. But I can tell you that, you know, the fundamentals, math, you know, physics, you know, computer science, those won't change too dramatically. How we apply them will change, and what they achieve will change dramatically.
Okay, I see. Interesting, very interesting so far. I mean, I guess the big question here is, because we're talking about sci-fi projects and we're talking about the future, is there already a quantum computer that exists?
Oh yes, many. We have almost 100 quantum computers and simulators, most of them quantum computers available on the Strangeworks platform. IBM probably has 20, 30 or more. Rigetti has a few. IQM, D-Wave, there's dozens of companies that are producing hardware that's pretty viable. Now, the experiments are still very small, and the number of qubits on some of them are small. But you have to be careful about thinking about the number of qubits, because that's a very classical way of thinking about it. And if you think about bits, we can compare those all day long. I can compare my Mac to a Windows machine, to a this, to a that, the Intel processor to the Apple Silicon, because a bit is a bit is a bit. But a qubit is not necessarily a qubit across all these architectures. So annealers have advantages in some areas, but some people say that maybe they're not even quantum. Superconducting is, you know, very popular. That's where you've seen those chandeliers. It's a dilution fridge, right? This is all cryogenics, and at the bottom's a little tube, and at the bottom is a thing about the size of my pinky fingernail. That's the quantum computer, right? All the rest of it is, you know, show for cooling it down. Ion traps, where you use lasers to trap the items. Each one of these, you know, I just was asked a question by a reporter after that other panel, and they said, which one's going to win? Is it going to be this type of computer or that type of computer? And the answer is, I think that's the wrong question. I think the question is, what's the total addressable market for each of these architectures? Because they will be better at doing different things. So, you know, it's a little bit different when you think about it from a quantum perspective. It's not necessarily a case of this feature happens or this machine is dominant, et cetera, et cetera.
But you did say that the market is accelerating, and I'm wondering, like, the same way that potentially, you know, in the 90s we didn't believe that the internet would be so revolutionary. In the 60s and 50s we didn't think that computers are going to be a thing. Quantum computing now you're mentioning is the future. So I guess my question is, would we also have it at home then? Does that mean that everybody will have a quantum computer?
So that's a great question. I'd like to start with two of my mentors, a guy named Bob Metcalfe, very famous guy, invented Ethernet and Xerox Spark and Polaris, all this stuff, and Tim Berners-Lee, who did the internet. You know, I had dinner with Tim a few months ago, and Bob, and Tim was like, "Oh, you're like me in the early days. You're running around yelling, the internet is coming, the internet." And people are like, "Oh yeah, that's nice, crazy person," right? I was like, wow, that doesn't make me feel amazing about my career choice right now. But yeah, it's you know, these things are hard to set timelines on, but that's a very apt, especially after Tim's comments, comment about my viewpoint, which is this is going to change your worlds more than you could possibly imagine. Things that were science fiction will become science fact as we start using actual atoms to compute on. Think about the atomic bomb and unleashing that power. This is the computing equivalent of that, like harnessing the power of the atom to do all this computational complexity. And so it's fascinating to me that, I don't think enough people are understanding just how big a change it is. And I think it's inevitable. I mean, when we first started the company, I said we wrote software for computers that didn't exist. And that was kind of funny, and we thought we were clever. And then a few years ago, I said, well, they kind of exist now, right? We've got machines between 17 and 80 qubits. And I said, they're not computers. They're really good lab equipment for exploring the quantum landscape, right? They're not quite there yet. And today, we're somewhere in between there and their actual machines. I mean, we have people, pharmaceutical companies, finance companies, companies doing material science, paying us money to do serious work on these machines now. All right, and so it's like, okay, they're commercially viable, they're available, they're not as powerful, but when were computers that powerful? How many of you had like an Apple IIc or a Commodore 64 or whatever, right? Now we know who all the old people are. We should all have drinks together later. Everybody above 50 is invited to drinks with me. No, I'm just kidding. but the thing is like, was that computer powerful when you're flopping a floppy disk? No, but at the time, it was like amazing. And what it led to, that's exactly what's going to happen with quantum computers. Right now, we're kind of in that Apple II stage, maybe. But the difference, again, and I said this in my talk, but I don't think I can emphasize it enough, is that when we started, there was hardly anything. It's only been 4 years. That in classical history is the equivalent of maybe 30 years or 40 years. So it's going to move much, much faster. As we get to 400 qubits, 1,000 qubits, which will happen in the next 12 months, I mean, that's a real thing. We'll start being able to use qubits to solve the fundamental problems in physics with the qubits. And that's just going to drive it faster and faster and faster. And so, I'm not tired of preaching that gospel. I will continue to preach it, and I will continue to see blank faces, and some people won't. But this is the biggest technological shift in the history of our species, and it will affect everything because it is using nature to compute. It is a chasm we have never before crossed. It's going to be big, very, very big.
It's going to be big. Well, I guess this is like in a conversation from before as well. I'm trying to wrap my head around it, yeah? In a lot of different things, a lot of different ways. Because what I'm thinking is, like, does it take conviction to believe in quantum technology? Like, because, I'm thinking, like, because there's so many things right now, especially if you're in the tech space, jumping from crypto to Web3 as terminology to like blockchain being the future to like AI being the future to, everything. But you have the strong conviction of, no, guys, quantum technology, quantum computing.
So quantum, as I said in the talk, though, is the first of a whole new evolution in computing science. I mentioned slime computing, right? That's a real thing, right? They use that in Tokyo. Quantum is kind of the starting gun for this change in computing, and there'll be other forms. It won't just be quantum, right? neuromorphic, amorphic, even analog compute, all kind of things that some stuff from the past, some stuff from the future. I don't think you can have a true AI without having a quantum computer. Okay. I also am a big AI critic, not because I don't love it, but because when I was working at Apple in the 90s, we knew about AI. And Doug Lenat, who did a famous project called Psych, was one of my mentors. And they had a very specific thing about AI. And that's the thing, is like we keep moving the goalposts. So what was AI in my day is a super intelligence in your day. Right? So we keep changing the terms, but the quantum stuff is much more simple. All of these things are a part of our future. Some of these things, like quantum, will be the key to unlocking those futures.
Like? No, half time. We've got more. We have 20 more minutes.
I thought he said it was
go.
time. I was like, thank you.
No.
Good night.
No. Mic not drop. We've got 20 more minutes of like conversation here. By the way, guys,
I'm out of comments.
No, mic drop. By the way, guys, because I can go on and just ask tons of questions here to Whurley, but if anyone has the need, the urge to ask something, and you are, a technologist, a scientist, and you want like you
don't have to be a technologist or a scientist.
No, you don't have to. It's just that I usually, I was just trying to complement this, like as a complimentary question. Okay, come. And how does it work? Okay.
Yeah, I could try, or you could hear me? Okay. So I have actually two questions. Yeah. One is why you actually mentioned evolution. I like this word, but what you are speaking is revolution. So what is slowing down us? Is this computer architecture or some kind of new architecture we have to think about? Yeah. Or we are not still ready to use
that's
it?
That's a great question.
And I have one more.
Go ahead.
Yeah. Because I have similar experience here. That's been 5 years long startup and miserable failure at the end. Yeah, what is actually driving you at our age? Yeah, to again leave family aside and kids and start again.
We'll do the questions in reverse order. Somebody has to show these youngsters how to do it, right? I feel like some of these old guys, it's like. Any of you guys, I don't know, I did not want to see the movie, but I watched it on the plane. I watched Top Gun. Anybody see the new Top Gun movie? It's like all the old fighter pilots. It's like, yeah, we still show you some tricks. but you ask a very important question, a more important question about architecture. Quantum computers are non-von Neumann architectures, right? Almost every form of computing we have is a von Neumann architecture. So it is an architectural shift, and it is both an evolution and a revolution, right? That's a very good point. But what keeps me going? I'm crazy, obviously. I have more resources now, so I can take much more risk, right? And I have the thing that keeps me going more than anything is I have what I believe is the greatest team in quantum and in software on the planet. A group of guys and gals that has worked together an average of 10 years, 15 years, 20, 25 years, 30 years in some cases, who were there when there was no iPhone and helped make that happen, who were there when there was no HPC and helped make that happen, right? And so I feel like if anybody can do it, this is the right team. And I believe so emphatically in this team that I will follow them to the end of the earth, right? Whether we're right or wrong. Startups are a team sport. It's not about me. My job is to support them. I do two things. I run air cover, right? And maybe a little inspiration. And then I support the team. I mean, I bring the developers beers. I take them for drinks in the afternoon. I make sure, new computer comes out. I'm already ahead of the game getting them the resources that they need. That's really my role, is more of a supporting role. And it's wonderful to be part of such an amazing team of creative people. And yeah, I contribute too, and so do my co-founders, and we're the older guys in the group. But it's really about this team that we've made, this community that we're a part of, and this global society that is going to be so dramatically affected by this technology, and they have no idea. And some people are just in quantum for money, and some people are just in it for a Nobel Prize. Everybody has their different motivations. I'm in it to make sure that it's as evenly distributed as possible, that everybody has a level playing field, that there are the right abstraction layers, that are all these things. And so with that as a goal, I feel almost like it's not what's driving me, it's what's demanded of me is, you know, with my success and with the other stuff that we've done, we have a responsibility to give back, and we have a responsibility to make sure that this new technology that's going to so dramatically change the world is done in an ethical way, that's done in a fair way, that this technology is used for mostly good, right? For us, it's not about the money. We're entrepreneurs, sure. Everybody there would like to sell the company. At some point, maybe, maybe not. Maybe we just want to run it forever and make money. But it's more of a passion project than it is a startup in many ways. And I think that passion, that's what's keeping us going and motivated. Look, developers have a lifespan of maybe 2 years, 3 years at a company or a project, right? Then they get bored. They want to move on somewhere else, okay? The fact that we're going to, in March, turn 5, and everybody that started is still on the journey, and new people is a real testament to kind of what's being built at Strangeworks, and I'm super proud of that more than anything.
Well, you did talk a little bit about culture and actually how to do it within, and I do actually like the direction that it's going, that being part of something and doing something, by doing that, you actually contribute to how it can be used in a proper way, right? And I think like when this discussion initially started, as when it was formed as a panel with Shahar as well, who's also the lead of the quantum computing institute, I'm not sure exactly the name, Quantum Delta, right, in Holland. Well, it was the idea of like, okay, so quantum computing destruction or disruption, or, you know, is it going to be can it be for good, or could it be something that can be utterly used for, you know, for the same way that, you know, we have nuclear power, right? It can be for good. It can, like, you know.
Sure, but this is the question about technology since the dawn of time, right? Like, at one day, I promise you, there was like, fuck, it's fire, and people are like, we could burn a lot of shit down with this, or cook food, right? This is a question that has been around for time immemorial, and so, you know, could someone use a quantum computer to create a gray goo that we couldn't stop that just turned the whole world into mush? Sure. Or maybe they find a new bioweapon, or all of these bad things. I can sit here and tell you a million bad things that somebody could do with a quantum computer that would kill all of us, or destroy the future, or kill the planet, or whatever.
Dystopian.
I choose not to look at those dystopian futures. I choose to think, wow, a quantum internet where you have even more privacy, right, and more security. Hey, I love that Elon wants to go to Mars. I get criticized for this. I don't want to go to Mars, right? If we go, everybody's seen The Matrix, right? How did Agent Smith classify our species as a virus? So if we wreck this planet and then we move to another one, sounds like maybe we are a virus, right? Like, why don't we use the billions of dollars to fix what we have, learn how to manage this before we go spreading out amongst the stars? I think that's super important. Quantum computing could be a big part of that. By the way, going to Mars, I can tell you there's a bunch of stuff that they haven't gotten to yet, problem set wise, that they'll need quantum computing to figure out, to optimize, right, to manage. So I tend to look on the positive side of it. There's plenty of good and bad with every technology, but I think in this case with quantum computing, the good far outweighs the bad. And given the fact that when I started, Nick Farina at AeroQ had already set up a quantum ethics group, right, as the industry was in its infancy. That's something I've never seen in the 30 years of my career, where the ethics and things like that, sustainability, all this, were being thought about at the beginning, at kind of the dawn of an industry. So I do give the quantum community credit. I think they're managing this in a very different way for the most part, and it's a wonderful community to be a part of.
Well, by the way, it still stands if anyone else wants to ask questions. Yeah, come.
Thanks. So I have read that IBM is working on 1,000-qubit quantum computer, and you have mentioned it as well. And I was wondering, what else besides of the amount of qubits is necessary to develop the whole thing, to make it advanced and make it like a valid technology for the future?
He wants to know where the dirty laundry is in quantum, so I can tell you this. So number one, building another qubit, adding it to a system, very, very easy. Adding it to a system without the fidelity of the system crashing so hard that you can't get usable data out of it, very, very difficult. So noise is the #1 problem right now in quantum computing. And the noise is a very complex problem because when you take, a salt atom and blow it up and pull an electron off and freeze it down or trap it with lasers or whatever version of it you use, nitrogen vacancies with diamonds, whatever you use, okay? It can be interfered with by the environment around it, unlike every computer. So you see a quantum computer, maybe it's about the size of this square around us, okay? It's very large, but inside it's not very big. And the reason is that's environmental shielding, right? Gamma rays, the rotation of the Earth, vibration. If you go to Microsoft's labs, their quantum computers are mounted on those like earthquake platforms, right? So they keep them perfectly level no matter what's happening in the environment around it. So there's noise. Number two is if we get past noise, we run into one of the most fundamental problems in computer science, error correction. And so the number of qubits we would need to have error corrected, so physical qubits versus error corrected logical qubits, is tremendous, right? So error correction is the second big thing. Outside of that, I guarantee you there are dozens of other problems that will halt the progression of quantum computing that we will use quantum computers to solve that we don't even know because nobody's ever done this physics before, right? So there's untold mass of problems we don't know and we don't understand. But, noise in the system and error correction, the two biggest things preventing us from getting to like the first kind of general purpose quantum computer.
That leads up to my next question. We've been talking about how influential quantum computing can be, but what if we looked at it in two ways, right? What could be exactly like the first years of quantum computing? What can we do in Okay. Can you hear me now? Yes? Okay. How did I do that? Okay.
I like that better. I could just make up any answers I wanted.
Okay, all right. Error correction. Exactly.
Developer humor. Love it.
Alessandro, do you have any questions too? No. Okay, all right. I'm continuing. So what I was saying is, my question was, what would be the short term and what can be the long term of quantum computing? What would be like the short term versus long term?
It's really easy. That's what I was talking about earlier. Short term, we use optimization to make everything more efficient, whether it's supply chain management, which we desperately need right now, or new chemistry for material science, or perhaps drug discovery. Those are all things being done right now, and that's what the near term looks like. Long term, discovering completely new things on the periodic table.
Different worlds, teleportation.
Right. Completely, it's like we say that, but I gave earlier the example of you used to cross the U.S. in a horse and buggy. It took months. Maybe your party died. Maybe you had to eat some of them. I don't know. And then you got the train, and it took like a week, right? And it's like cars, right? You can remember, people, they didn't want a car. They wanted a faster horse or whatever, right? There's all these examples through history. So we are now at a point, what I believe is the greatest time in history to be alive, because everything that you fantasize about could be a possibility in the next 100 years, right? Like we've reached a point where it's amazing. Like for the four old guys in the room, when we used to do our projects that you guys are doing, we would have to cut out UPC codes, like barcodes out of cereal boxes, and ride our bike or walk to a post office, like a physical email, right? And it took months to get stuff. My son started a startup last week. He applied for a credit card. He had Amazon compute infrastructure instantly. He had, went to Apple. They'll give him a computer for $34 a month or whatever. He's done. That technology 30 years ago, governments had that technology, right? 50 years ago, nobody had that technology, right? 100 years ago, that was even beyond science fiction. So the world is changing, and this technology is going to unlock these incredible things. But the future, it's whatever you can imagine.
Go.
Okay, so I'm sold. Okay, I'm a developer or a data scientist. I don't want to get a PhD in physics, and I don't want to use the equivalent of punch card. Where do I start?
Yes, we talked about the punch card earlier. So look, I would normally tell you could start at quantumcomputing.com, which we built a bunch of free resources and algorithm stuff for you to go play with it and learn about it. We're about to take that completely out. But at the end of the month, you go to strangeworks.com, all of those resources will be in a new system, which we're releasing the latest version of our product, and it will be free and consumption-based. If you have a really good idea, once you get used to it, like I said, we will sponsor that idea. We're trying to get as many people as possible into it. As a developer, though, quantum computing, Stack Overflow, Stack Exchange, we set that up. There's 14,861 people in there as today to answer questions, to share code, to do stuff. And hopefully, we can't say with who, but everybody will guess, with a large code repository soon, we'll be announcing a bunch of more free code and stuff to get people kind of going.
I'm one of the old guys, so books? Something to
okay, so
start
I've only
learning
written
from?
one book on quantum computing, and physicists hate it.
Also 3 more minutes.
Okay, it's Quantum Computing for Babies. It's made of cardboard. It really is. And some physicists tried to get it peer reviewed, and I was like, really? It's made of cardboard. It's like 12 pages. It's a good book, though. It's a very good book, if I do say so myself. There's a lot of good books. I would go to the textbooks, not the books, right? Scott Aronson's book is awesome, and it explains a lot about it. Jack Hidry has a great book. You know, these are friends of mine. They have awesome books. But for developers, from your standpoint, I'd actually go more to the textbooks of here's the code, here's the algorithms, here's the stuff. It'd be much more useful. Of those, I would start with Quantum Information Science, which is a very well-known textbook on that. It's very good. It's very heady, but it's really, for a developer mind, I think it's a really good starting point. So maybe we have time for one more quick question from the audience if somebody has one, or you can throw one out. This is perfect.
Is it
down.
Oh, all right. Boom.
Come on up.
Come up.
No, you got to talk in the mic so everybody else can hear you. Please.
Thank you. So I want to see your view towards the artificial general intelligence and the role of the quantum computing. And let me put some context on it. I'm not like talking about reducing the training time from months to minutes. This will be just super fast expert system, in my opinion, given that my limited knowledge. So I want to see your view. My second question is, comparing the supercomputer, what is the energy requirements of running quantum computer?
What's the second part? Was compared to supercomputers what?
Energy consumption of the running the...
Oh, yeah. Great question. Yeah. Great. All right. That's a phenomenal question. Well, so to start, because I don't want to forget both of your questions, you know, my view on AI is tainted, okay? It's tainted because in 1984, a guy named Doug Linnett started a project called Psych when he was kicked out of CMU and Stanford for saying AI would never be a possibility, that the only thing he could do was have these very complicated inference engines. He's still working on Psych today. Like I said, when I started, what we call AI is what now is a superintelligence, or we keep moving the goalpost, and that's because what we have in AI today, in my opinion, isn't any kind of intelligence. It is amazing automation. It is the greatest automation we have ever seen, and it's phenomenal, but it's not intelligent in any provable way, right? So that kind of sums it up, right? So now everybody can send me hate mail, but you ask a really great question that I love. You said, compared to a supercomputer, what is the kind of the environmental impact, the energy usage of a quantum computer? It is far, far less, okay? These things have a tremendous environmental advantage for the type of calculations you can do. So you look at, this is why I earlier somebody asked me about blockchain. I'm not a fan. Why? Because it's the worst thing that happened in the environment in computing history. But I believe, these things are going to give us more power than supercomputers at a fraction of the environmental cost.
Well,
I think we're done.
So also quantum computing saving the environment one computer at a time.
That's my only goal with it.
Ladies and gentlemen, Whurley here.